Today's learning target is I can apply my knowledge of angle relations to describe angle relations. So I want you right now to pause me, and I want you to answer the do now questions. Okay, so let's go over this. So the first one, they are vertical, they are across from each other. The second one is adjacent and complementary. They're adjacent because they're next to each other. We know that this is 90, so complementary angles add to 90. The third one, they are adjacent, supplementary, and linear pairs. Okay, it adds to 180. 4, they're adjacent, they're next to each other. 5 is a little more challenging. It is vertical and complementary. Okay, so let's go over this. This is 90, this is 90. We know that this symbol right here means congruent, so they both have to be the same angle degree. So that means this has to be 45, 45, and this is 45. So angle 1 and angle 2, when you add them together, you get 90. Okay, so that one was a little more challenging, but if you got vertical angles, I was happy. And the last one is vertical angles and supplementary. Okay, we can't say linear pairs just because they're not on the same line. If they were on the same line, then we would be able to say linear pairs, but they're supplementary because if this is 90, this one needs to be 90. They're vertical, so we know they are equal. Okay, all right, so that was the do now. Okay, so let's go over this. So perpendicular lines, they intersect to form 4 right angles. They intersect to form congruent adjacent angles, and the right angle symbol indicates that the lines are perpendicular. So if I see a right angle, I can always say my lines are perpendicular. If I see the perpendicular symbol, I can assume that my angles are 90 degrees, okay? And that's your symbol. So I only wrote one right angle there, but I could have wrote all of them, okay? Just know that perpendicular lines and right angles go hand in hand. Okay, perpendicular bisector is a line segment array perpendicular to the segment at its midpoint. In the diagram, LM is a perpendicular bisector to PQ. And remember, bisector cuts in half. So now we have a perpendicular bisector. It forms a right angle and it cuts a line in half. Okay? So let's try this example. So we're going to write another name. So here's my diagram. We're going to write another name for CBF. And this is kind of like a review for your exam on Friday, okay? So CBF. So here's CBF. Another name for that would be FBC. Okay, we got to keep the vertex in the middle. So now we have, name the sides of EBD. So EBD, EBD, my sides would be EB and BD. Classify A, B, C. So I'm going to classify this. So what it means by classify, it means is it a straight, obtuse, right, or acute. So in this case, it is straight. Give an example of an obtuse angle. So I look at this and I want to give an example of an obtuse angle. I'm going to say angle ABF. Okay? There's other ones. Angle EBD is another one. So whatever you put there, that's okay. Name 2 congruent angles. Remember, vertical angles are congruent. If they have this little symbol right here, they're congruent. Okay? So my 2 congruent angles are angle EBA is congruent to angle CBF. And now name the perpendicular bisector. So I'm just going to erase this so we can see. or maybe not. Okay. We're looking for that right angle. So I see a right angle right here. Okay. So that means that I have a perpendicular bisector, BD, and it cuts AC in half. So my perpendicular bisector is BD. So we can say that BD is perpendicular to AC. Okay, but it's asking for my perpendicular bisector. Okay, so what I want you to do is I want you to take a second. I want you to pause me, and I want you to answer as many questions as you can. Okay, so name the vertex of angle 2. So the vertex of angle 2 is T. Right here is angle 2. Name the sides of angle 4. Here's angle 4. So the sides would be WT and ZT. Name another angle for angle 3. So here's angle 3. So another name could be angle ZTU. Write another, and you could also UTZ. That works too. Write another name for angle 1. So angle 1's right here. So angle YTX or XTY. Classify I'm going to erase this so we can see it. Classify YTW. Right. YTU. Obtuse. XTU. Acute. WTX. Straight. Okay. Name two perpendicular lines. Remember, we're looking for a right angle. So what two lines form that right angle? We have WT is perpendicular to YT. Name an angle bisector. So remember, an angle bisector cuts an angle in half into two congruent parts. This right here means congruent. So my angle bisector is UT. It's what cuts it in half, or TU. Okay. So pause me, write that down if you didn't write that down. And then unpause me. Okay, last problem. Determine whether each statement can be assumed from the figure. So can I assume that angle 4 and angle 7 are vertical angles? Yes, because, actually, you're supposed to pause me. Pause me. Answer these questions, and then unpause me, and I'll give you the answers. So, yes, we can assume that angle 4 and angle 7 are vertical angles because they are across from each other when I make that X. Can we assume that angle 4 and angle 8 are supplementary? Yes, they're on a straight line. Okay, here, I want you to write perpendicular. Can we assume that P is perpendicular to T? Yes, there's a right angle. Is angle 3 and angle 6 congruent? No, we can't assume that. Okay, we don't see the congruent symbol. We know that it adds to 90, but we can't say that they are congruent. Can we assume that angle 5 is congruent to angle 3 plus angle 6? Yes. Okay. So this is yes, because if this is 90, then this has to equal 90. No matter what angle 3 and angle 6 is, when you add them together, they have to equal 90. So we know that they are congruent to each other. And angle 5 and angle 7 form a linear pair? No. Okay? So pause me and get that down. If you have any questions about this, let me know. Perpendicular bisector is really not a big part in here, but I just wanted to go over it because it kind of was like a little bit of a review for you guys for your exam on Friday.